This is Mars, 400 million kilometers from the nearest garden. The surface temperature right now is minus 53 degrees Celsius. By tonight, it will drop to minus 80. The air pressure out there is less than 1% of what your lungs are used to. If you stepped outside without protection, your blood would begin to boil within seconds. And the soil, if you can call it that, hasn't grown a single living thing in over 3 billion years. It is not sleeping. It is not waiting. It is simply dead. The dust that coats everything here is iron oxide, rust. The whole planet is rusting away, slowly, in silence. Beneath the surface, things are worse. The regolith, the broken rock and mineral powder that passes for soil on Mars, is laced with a class of chemicals called perchlorates. On Earth, we use perchlorates in rocket fuel and explosives. Here, they saturate the ground at concentrations that would kill most bacteria within minutes. There is no nitrogen in the soil. There is no organic carbon. There are no earthworms, no fungi, no microbial networks, none of the invisible living infrastructure that makes Earth's soil one of the most complex ecosystems on the planet. From orbit, this place looks almost beautiful, a vast red landscape, ancient and still. But from down here, standing on it, the truth is clear. Nothing should be able to grow here. And yet, someone decided to try. Before anything goes in the ground has to talk. A glossy skeleton farmer kneels in the red dust, pushes a soil sensor probe into the Martian regolith, and waits. The field tablet lights up. pH 4.1, far too acidic for any root to survive. Perchlorate levels, dangerously high, toxic to almost every living organism on Earth. Nitrogen, 0. Organic carbon, 0. This soil isn't just empty, it's hostile. But here's the thing about hostile soil. Every number on that screen is a problem that has a solution. The farmer looks at the readings, then looks at the land, then gets to work. The soil readings are in. The problems are clear. Now the real work begins. Step 1. Break the land. A massive tracked subsoiler rolls onto the field. Its heavy steel tines drive 60 to 80 centimeters straight down into the compacted Martian regolith. The ground that has been locked solid for billions of years tears open for the first time. Red dust rises in slow clouds behind the machine. Furrows stretch to the horizon. But broken soil is not enough. This soil is still poisoned. Step 2. Kill the poison. A large tank-mounted spray rig moves across the ripped surface, boom arms extended wide, releasing a fine mist of bacterial solution across the broken ground. These are specialized microbes, bacteria that consume perchlorates and break them down into harmless compounds. The soil hisses faintly as the mist settles in. Step 3. Feed the earth. A soil mixing auger machine moves in next, dumping loads of black biochar pellets and dark organic compost directly onto the reddish, broken soil. The auger churns them together, black into red. For the first time in the history of this land, there is carbon in the ground. Biochar is extraordinary. It acts like a sponge, holding water and nutrients inside its microscopic pores long after they would normally evaporate in the dry Martian air. Step 4. Plant the invisible army. A precision microdosing injector rig moves slowly across the blended soil, pushing small probes into the ground at precise intervals. Each probe delivers a dose of nitrogen-fixing bacterial culture directly into the soil. These bacteria have one job: to pull nitrogen from the thin Martian air and lock it into the ground. Without nitrogen, no plant on any planet can build a single protein. Step 6. Correct the chemistry. A broadcast lime spreader moves across the field, releasing fine white agricultural lime powder that drifts slowly over the dark blended soil in the cold Martian air. Martian soil is too acidic. The lime reacts with the soil chemistry and slowly raises the pH, pushing it closer to the neutral range that plant roots need to absorb minerals. The field is starting to look different now, darker, more alive. Step 7. Shape the rows. A bed-forming machine moves in and begins sculpting the prepared soil into clean, raised rows, 30 to 40 centimeters high, perfectly uniform, stretching to the horizon. Raised rows drain water away from the roots. They also warm faster in the cold Martian air, creating a slightly warmer microclimate just where the seeds will go. Step 8. Lay the water lines. A small tracked vehicle moves slowly down each row, trailing an automated pipe-laying attachment behind it. Black drip irrigation tape unrolls directly into the soil surface of each raised bed. Every drop of water on Mars is precious. There is no rain here, no groundwater to draw from. Drip irrigation delivers water molecule by molecule directly to the root zone. Zero waste, zero evaporation. Step 8. Install the eyes of the farm. The machines stop. Now it is the farmer's turn. Glossy skeleton farmers move down the rows on foot, hand-pressing small electronic soil sensor stakes into the ground at regular intervals. Each stake monitors moisture, temperature, pH, and nitrogen levels in real time. As the pink Martian dusk settles across the field, the sensor stakes begin to glow. Tiny LED lights blinking softly in the rows like a constellation laid flat on the ground. The farm's nervous system is now alive. The land that was dead this morning is ready to grow something. Day 1. The rows are ready. The soil is prepared. The sensor network is watching. Now comes the moment everything has been building toward. The seeds. Watermelon seeds are small, flat, pale cream-colored. They look like almost nothing. It is difficult to believe that something this size could become what we saw at the beginning of this story. But every giant thing starts here. A glossy skeleton farmer kneels at the first row, fingers pressing a single seed into the dark, prepared soil at precisely the right depth. 2 centimeters down. Not 1, not 3, 2. Too shallow and the seed dries out before it can germinate. Too deep and the seedling runs out of energy before it ever reaches the light. 2 centimeters. Every time, down the entire length of every row. The drip system activates for the first time. A faint hiss along every tape line. Then silence. Then the dark soil around each seed begins to darken slightly as the first water reaches the root zone. The seeds are in the ground now. They are alone in the cold Martian soil. No warmth from above. No rain. No insects, no earthworms moving through the dark. Just the sensor network watching, and the bacteria already working in the soil around them. In 4 to 6 days, if everything holds, the first pale shoots will push upward through the dark surface. The farm holds its breath. Day 4. Nothing yet. The soil surface looks exactly the same as the day the seeds went in. Dark, still, undisturbed. But 2 centimeters below, something is happening. The seed coat is softening. The first root tip, called the radicle, is pushing downward into the dark soil. It is thinner than a human hair. It is already working. Day 6. The first pale shoots break the surface. They are almost nothing. Tiny, folded, pale green hooks pushing up through the dark soil. Fragile and almost translucent in the cold Martian light. Each one carrying 2 small seed leaves, called cotyledons. The seedling's first and only food supply, until the roots can feed it from the soil. Above the rows, the growth scanner gantry moves silently on its rails, its multispectral cameras scanning every centimeter of every row. It sees things no human eye can see: stress signals, nutrient deficiencies, temperature irregularities, all before they become visible problems. Day 14. The micronutrient applicator robot moves slowly between the rows, reading the growth scanner's data and delivering precise doses of liquid fertilizer to individual plants flagged for support. Day 23. The vines are running now. Long climbing stems reaching outward from each plant, wrapping themselves around the bamboo support stakes the farmers have pressed into the rows, the tendrils curling tight with the instinctive grip of a plant that has been climbing toward light for millions of years of evolution. The canopy is thickening. Row by row, the dark soil is disappearing under a spreading blanket of green. Day 31. The first flowers appear. Small, pale yellow, 5 petals each. They open in the morning and they close by afternoon. The window for pollination is narrow. There are no bees on Mars. Day 33. The flowers are open. The pollination drones are working. Everything is on schedule. Then, the sky changes. On the horizon, a wall of red. Not clouds, dust. A Martian dust storm moving fast across the open desert toward the farm. A rolling curtain of iron oxide particles traveling at 60 kilometers per hour. Enough to strip unprotected leaves, clog sensor equipment, and bury the drip lines under centimeters of fine red powder. The farm's alert system fires. The skeleton farmers move fast. The climate canopy tunnel structures seal shut along every row, transparent panels locking into place over the vines, internal fans reversing to create positive pressure inside, pushing outward so no dust can enter. Within 4 minutes, every row is sealed. The storm hits. For 40 minutes, the farm disappears inside a wall of red. The sensor network keeps reading. The drip system keeps running. Inside the sealed canopy tunnels, the flowers stay open. The temperature inside holds steady, while outside it drops to -40. Then, the storm passes. The farmers emerge and begin clearing. Red dust has settled over every surface: machinery, sensor stakes, the outer canopy panels. But inside the tunnels, the vines are untouched. The flowers are still open. The pollination drones resume immediately. Day 35. The farm is quiet again. The vines are healthy. The flowers are beginning to set. Then the ground moves. Not wind, not machinery. Something beneath the soil. A low subsonic vibration travels through the soil, felt before it is heard, and then the regolith at the eastern edge of the farm erupts upward in a shower of red dust and broken soil as something enormous forces its way to the surface. A Martian worm. It is vast, longer than 3 of the farm's largest machines laid end to end. Its pale, segmented body as wide as a grown farmer is tall, its blind head sweeping slowly left and right as it breaches the surface, sensing heat and vibration through organs that have never needed eyes in 3 billion years of underground life. It moves toward the nearest rows. The leading edge of the worm tears through the eastern section of the farm, vines collapsing, bamboo sticks snapping, soil erupting from below as the creature moves through the prepared beds, its body too large and too ancient to understand what it is destroying. Half the farmland is damaged before anyone can respond. The skeleton farmers do not reach for machines, they reach for their bows. Each farmer carries a traditional longbow, not a weapon of war, but a tool of signal and direction. The arrows tipped not with blades, but with bright, burning flare heads that produce intense light and a sharp cracking sound on impact. The farmers spread wide around the worm's path, moving fast, keeping distance from the creature's blind head and the unpredictable thrash of its tail section. The first arrow fires. A bright flare cracks against the soil beside the worm's head. The creature reacts immediately, rearing back, its head swinging away from the light source, the vibration of the impact traveling through its body. The farmers work in formation, each arrow driving the worm's head further away from the surviving crop rows, redirecting it toward the open desert at the farm's western edge, step by step, flare by flare. It takes 11 minutes. The worm does not die. It is not hurt. It is simply redirected, its blind, ancient instincts responding to the light and noise and turning it back toward the deep desert where it belongs. It disappears back into the regolith at the farm's edge, the ground closing over it as if it were never there. The farmers lower their bows. For a long moment, nobody moves. Then, the work begins again. The eastern section is assessed. 40% of the rows are damaged, vines torn, soil disrupted, drip lines severed in multiple places. The sensor network in the damaged section is offline. It is not a disaster. Not yet. The farmers begin repairs immediately, reforming damaged rows by hand, relaying drip tape, repressing sensor stakes. The growth scanner gantry runs a full damage assessment pass over the affected rows. What survives in the undamaged rows is still healthy, still flowering, still on schedule. The farm does not stop. It never stops. Day 90. The vines have been running for weeks. The canopy is dense, and the flowers have long since closed and fallen away. And beneath the leaves, they are there. The watermelons. They had been growing in secret under the canopy, hidden from view, fed by the drip system, monitored by the sensor network, warmed by the climate canopy tunnels through every cold Martian night. And they are enormous. It is bigger than anyone expected. The skin is dark green with pale stripes. The surface is hard and smooth and cool to the touch. The yellow ground spot where the fruit rested against the soil tells the farmer what they need to know. It is ripe. The Harvest Assist Arm robot moves slowly down the first row, its robotic arm extending carefully beneath the canopy leaves, gripping each watermelon with a precise, controlled pressure, firm enough to hold, gentle enough not to bruise, detaching each fruit from the vine with a single clean twist. The skeleton farmers walk alongside, hand-checking each piece as it is lifted free, row by row, fruit by fruit. Then, at the far end of the eastern repaired section, a farmer kneels beside a vine and pushes the leaves aside. The watermelon resting there is different from the others. It is the largest fruit on the farm, possibly the largest watermelon ever grown off Earth. Its dark green skin stretches taut over a fruit so heavy, the vine beneath it has flattened against the soil under the weight. The farmer calls the others over. It takes 3 of them to lift it. They carry it together to the center of the farm and set it down on the dark prepared soil between the rows. Then, one farmer picks up a long knife. One clean cut. The watermelon splits open. Deep red flesh, jet black seeds, fresh juice running down the cut face and dripping on the red Martian soil below. The contrast of vivid red against orange-red Martian ground. Breathtaking. Nobody speaks. On a planet where nothing should grow, where the soil was poison, where the air is too thin, where there are no bees and no rain and no warmth. A watermelon just opened on Mars.